Okay, so one of the forms of transfer, not transform, and my students do have a hard time hearing the difference, so I have to be sure to enunciate that. When energy is transferred from one place to another, one of those methods is from radiation. A lot of times that's just a word they hear and they sort of know it comes from the sun, and then they really don't grasp it too well. It's a little bit difficult to measure sometimes. So these are radiation cans. They're made out of metal, and then they just have different colors of paint on the outside. My experience is they know pretty well that things that are dark absorb heat, which is actually the radiation, and then things that are light tend to reflect it, but they mostly just sort of regurgitate that information. They don't really have not had any experience. They've not quantified it in any way. They just sort of say it because that's what they've been told. So these cans are a way of helping to actually measure that. They're pretty confident that the black one is going to absorb the most. When I ask them which one absorbs the least, they struggle a little bit. They're not sure whether it's going to be the white or the silver because that kind of is reflective. And so I get some mixed answers there, which is a good way to say, so what do you think and how can we find out? So these have had water put in them. They have just rubber stoppers. The nice thing about these stoppers, they have little holes in them, which is perfect for these probe thermometers. So we set this up, put the probe thermometers in each of these cans. So the water should come up high enough in the can that the tip of the thermometer is in the can, in the water. You'll need to remind them to make sure that you are measuring in Celsius if that's what you want them to use, which I generally do, or it also records in Fahrenheit, but they need to be consistent with what your directions are because it's very easy to have the wrong one. And then when you're talking about the data that you've collected, they don't understand why their numbers don't look anything like somebody else's. And obviously you can talk about human error and things like that and outliers of data, but when it's that significantly different, it's probably because they have not followed the directions correctly. So after you have them turned on, you're going to take an initial temperature just to see, and then you're going to set these under a light. It generally doesn't work very quickly if you leave them in the window, so that for this you will need to have a clamp light to shine on these. I usually let them go sometimes 5 minutes, sometimes 10, depending on how much time you have in class at the moment. But then at the end of that time period, you could either be collecting data every minute or two, which helps keep them engaged, or if you want to do something else at the same time and just refer to it then at the end of that time period, that works well also. Some of them are very fidgety and they need something else to do, and some of them are fine just looking at the thermometer for 10 minutes straight. But at the end of the 10 minutes, then you will have recorded the differences, and that way you have actually quantified. You can have the discussion about why the different ones have different temperatures and where the most amount of radiant energy has come from, being absorbed, and then being changed into the heat in the inside of these. Another way, this is just sort of a fun thing to do for radiation, because I think that they tend to forget. They might have heard about I'm sure they've heard of using sunscreen to protect from UV light, for getting sunburned and things. I don't think they realize how often they are exposed to that and exactly what's going on. So these are some UV beads. Sometimes we have glow-in-the-dark beads or whatever. So I just usually give them a piece of heavy twine and make little bracelets out of them. Most of the time I don't introduce what it is. We frequently are running late at the end of class, and so it's not uncommon for me to start something and tell them we'll finish the next day. So I often just give this to them and have them put it on, tell them we'll talk about the next day, and let them be surprised that these beads then change colors when they are in the presence of the radiation from being outside. And so that's a fun thing for them to discover. Even the boys like to wear them, a little bit surprisingly. In 6th grade, they don't mind putting it on. They probably just think it's, their crazy teacher wanting to do one more thing, but they do wear them. So they are seeing them when they change classes or go home, they are exposed to the radiation and it changes colors. Another way you can use those beads, which I have done on occasion, is to use them and test different sunscreens on them. And because sunscreens obviously are supposed to protect from the radiation, and so if you put a light coating on the different beads and expose them to under a light in your classroom, you can see which ones are better at protecting from that light, from that radiation, which is kind of a fun thing for them to do. Lets them know, this is real life application, how well do these sunscreens work if they were going to purchase them. Sometimes we ask them to understand, these concepts, and they can be kind of difficult. So we act out these concepts or draw models or different things. So this is one way that I have done this also. So in my class, I have a little stuffed animal, which I did not bring, but we will use the toy, this toy, and I just call it Buster, and the kids know Buster. So in class, we can act out, if Buster is this energy, how does this energy move from one place to another? How is it transferred? So in conduction, we would have people lined up, and Buster would get passed from one person to next, because the molecules, which are what the people are representing, stay in one place, and so you're just passing Buster from one person to the next. And then the energy packet gets moved from one spot to another. In convection, we don't have it being passed from one to the next, so Buster is being held by one person, and that molecule is carrying Buster to the next place. So you see the line is just moving Buster along, staying with the same molecule. And then with radiation, well, that goes through empty space. So Buster flies to the other side.